Alright, today's lesson deals with two new similarity postulates. The one we did the other day was angle-angle similarity. So we're adding these other two to the list now. So now we have side-side-side and side-angle-side. These other two were used in congruence, but they can also be applied to similarity. So starting off, side-side-side similarity. If the corresponding side lengths of the two triangles are proportionate, or proportional, then the triangles are similar. So the key thing, each of these sets of corresponding sides must be equal. So you have to compare AB to RS, and we'll say that comes out to 1/2. Well, that means BC over ST must also be 1/2, and CA to TR must also be 1/2. That would be an example. But this is what you have to write to be able to prove side-side-side. Earlier we had angle-angle-angle. What do you need to prove that? You needed two sets of angles congruent to each other. So this is the proof or explanation for angle-angle-angle. You had two sets of angles. For side-side-side, you need three fractions in a statement of proportionality. We'll talk about side-angle-side here in just a little bit. On example 1, it says, is either DEF or GHJ similar to ABC? So we're comparing these back to that one. I'm comparing this one back to this one. I want to see if this one right here is similar to the other two triangles. So the first thing that I always like to do is decide which one I'm going to compare back to ABC. I would pick maybe DEF. I'm going to compare DEF back to ABC. What I like to do is find the smaller of the two triangles. Which one of these two is the smaller one? DEF. And what's the smallest side on that one? 4. I'm going to start there. I'm going to look at the smallest side on DEF and compare it to the smallest side on ABC. 8. What's 4 over 8? 1/2. Next up, I'm going to compare the medium-sized sides. What's medium on DEF? 6. And what's medium on the other? And what's that simplify to? 2/3? Automatically, are these simplifying to the same fraction? No. And so I would say this. I would say triangle ABC. Is it similar? No, it is not similar to triangle. Is it DEF? Yep. Why? Because these two fractions didn't simplify to be the same term. Next up, we have to compare that GHJ triangle. So I'm going to compare that one over here on the edge. So out of these two now, which one's smaller? The ABC is smaller. And what's the smallest on ABC? 8. And I just like picking the smallest one first because it makes nice, neat little fractions compared to improper fractions. So 8 is going to correspond to what over here? 16. So they're both the smallest number on each of the triangles, and that's 1/2. I want the next one up, so the medium side. What's the medium side over here? 9, and that corresponds to the medium over here, 18, and guess what? It's 1/2 as well. The last one is going to be 12, corresponding to 24, and that's 1/2. Since they simplify to the same fractions, then we know all the sides are proportional. And you could have written it like this. We could have said 8/16 equals 9/18 equals 12/24. This is kind of how the theorem or the postulate was written out. And that would have been just fine. The key thing, though, is you have to say that triangle ABC is similar to triangle GHJ. That's the key thing. Why? Because these sides are proportional. That's a statement of proportionality whenever you have letters. It's just an extended proportion whenever you have numbers. All right, example 2 says find the value of x that makes ABC similar to DEF. Now on this one, you have to intelligently pick out pieces or else you're going to have a little difficulty. So ultimately the goal is to find the value of x. So once again, I suggest looking at the small triangle first. So what's the x value there? Okay, so we'll start off with x minus 3. And that x minus 3 piece corresponds to what on the other triangle? 20. Those pieces correspond. Now I need another fraction that relates the two triangles. So I usually do small over big. Oh, 4 over 10. That's nice. Makes it simple. How do you solve a proportion? Cross multiply. So I like to do the easy cross first. That would be 20 times 4. So that's 80. Now the other cross, be careful. What should I write there? Okay, so I like to do this for some students. Put that in parentheses. That way they remember it's a group. And just write out 10 times the group. That's a good practice because that should remind you to distribute to both terms. So I already heard you all say 10x minus 30, and that's correct. Now it's a two-step equation. What do I get rid of first?
30.
And how do I get rid of 30? Add 30 to each side. And how do I get x alone? Divide by 10, and we get x is 11. Try these two checkpoints. Make sure to read them carefully. All right, so for some of these, they've been a little bit more challenging for you guys, so make sure to focus on this. First up, which one of these are similar? So we got to pick out pairs of these to compare. For some reason, I just always start with the smallest one. It's just how I work. I don't know why. All right, so here's the smallest one. Which one do I want to compare that to? I'm going to compare it to this one, okay? I'm going to compare it up to ABC, just to see how they compare. So I'm comparing the smallest to the biggest. All right, let's get a number from the smallest. Let's get the smallest number on the smallest shape. What do we want that to be? 18. All right, and the smallest on the big shape would be 38. And that simplifies to 9/19. Kind of odd. Next up, let's look at the medium numbers on both of these. What's the medium number down here? 21 corresponds to what on the other shape? 42. Well, that simplifies nicely to 1/2. Are they the same, though? All right, so I would say triangle ABC is not similar to triangle XYZ. Some of you just put these random fractions all over the place and didn't have any clue on which triangles you're talking about. I stress to you to write this out. That way you know what your comparison is concerning. So next up, let's maybe try the small and the medium, see how they do. So smallest number once again is 18. On the medium, what's our smallest number? 30. So that's 9/15, 3/5. All right, so medium numbers now. Medium numbers would be 21, 35, so that's 3/5. Now the biggest numbers on those two triangles would be, and that simplifies to 3/5. Are they similar? There we go. So triangle XYZ is similar to QRP. There we go. There's our similarity. And I can automatically see that this statement goes with these fractions. This statement goes with these fractions. They're grouped together. Yep. All right. So on accident, I put XYX. It should have been XYZ. Good catch. On number 2, it says, suppose ABC is not given. Sorry, suppose AB is not given. So I'm going to mark this one out and just put a variable now. We'll call it, we already had X, Y, and Z, so let's put like K. We're going to solve for K. I'll set it up on my proportion. What piece corresponds to K? Down here. 18. Now I need 2 other numbers. So I did big over small. I got to be consistent. Big over small. 42 over 21. Okay. Well, QRP. So we need to switch these real quick. I got to compare ABC to QRP. So K corresponds, that's the smallest side, corresponds to the smallest side here, 30. And biggest side corresponds to the biggest side here, so 54 over 45. Cross multiply real quick and tell me what you get. So I heard 36. That's correct. So this number should be 36. Good job. The next theorem we have is for side angle side. And if you remember, you had this back when you did congruence. And side angle side, you had 2 sides and the angle in between them. That's the key concept for side angle side. So once again, if an angle of one triangle is congruent to an angle of another triangle, and the lengths of these sides are proportional, then the triangles are similar. So here's what you need for side angle side. To prove side angle side, you need the angles to match up, and you need the sides that connect to it to be proportionate. So you need one pair of angles and then a proportion. That's what we're going to try to do down here. I know it's a complex looking diagram, but it's not too bad. It says you're drawing a design for a bird feeder. Can you construct the top so it's similar to the bottom using the angle measures below? So real quick, for side angle side, we see up here we need some angles. Are the included angles congruent? Are they congruent down here? Does 87 equal 87? Yes. So let's write out. How do they name this angle? Oh, they name it at letter B. It's congruent to angle E. All right, there's the angle piece. We've done that now. Now we need that proportion. We need to see, are the sides proportionate? So let's pick a number on the small triangle. What number? 20. So this 20 right here corresponds to 32 up here. 20 over 32. That's 10 over 16, 5 over 8. But I don't need just one fraction, I need another one. So the other one would be 20 over 32. Well, we already know that. 20 over 32, 20 over 32, that's another 5 over 8. So right now, we have side angle side. And here's how you could visualize it. Now it is side angle side. So if this angle is in between, we have sides, angles, sides. I know it's kind of cramped a little bit, but there's the side angle side right there. Sides, angles, sides. All right, this checkpoint's a little bit different, but if you understand equilateral triangles, it's not bad. It says, think back to that bird feeder in which you had 2 different triangles stacked on top of each other, but now you have equilateral. So I'll draw them just kind of shaped a little bit different. That's definitely not equilateral. Let me do that one more time. Shout out some numbers for this one. 5, so what's this one? They're all 5s. Shout out some numbers for this one. 7, 7, and 7. These are equilateral. That means all their sides are the same. What are the angles on an equilateral triangle? They should all be 60s. All right. Now, if they're both equilaterals, will they be similar? Okay, once again, what's it mean to be similar? Same angles, sides are proportional. You need to write that down and study that. That is what similar means. So, are the angles the same? Definitely. Are the sides proportional? Well, let's write them out. Smallest triangle, what's the smallest number? 5. What's the smallest number here? 7. Oh, another 5/7 and another 5/7. Are the proportions the same? Yes. So are these triangles similar? Yes, definitely. So once again, your explanation for equilateral triangles would be this. All the angles are the same because they're all 60s, so that matches up to here. And then all the sides are proportional, and here's an example. That could be your explanation. On this next page, we have a quick little review. These are the 3 things we can use to prove triangles are similar. The one we had in the past was angle-angle similarity. So you had to prove that 2 sets of angles, or 2 pairs of angles, are similar. So your answer should look something like this to prove angle-angle similarity. For side-side-side similarity, you need to be able to prove that 3 fractions are proportionate. So let's write that out. 3 fractions are proportionate. Obviously, they're corresponding as well. This top one up here stated that 2 pairs of angles are congruent. The last one, you need to be able to say that the angle in between the proportionate sides, the angles are congruent, and they're in between these proportionate sides. So you need 1 pair of angles and 2 fractions are proportionate. So I'm going to emphasize this one more time. For side angle side, make sure the angle is between the sides that you're examining. Make sure the angle is between the sides that you're examining. So be careful. Make sure the sides meet at that angle. It's called an included angle. All right, here we go. Last example. On example 4, it says, tell what method you would use to show the triangles are similar. So we have to pick between angle-angle, side-side-side, and side-angle-side. First off, can we say angle-angle similarity on this example? Do we have 2 sets of angles on each? Could we prove? No? You could probably prove 1 set, but can't prove 2. All right, next one is side-side-side. Could we use side-side-side? Why not? We don't know the third sides. So maybe be able to use side-angle-side. Let's see. First thing you got to be able to do on side-angle-side, find that angle. Do we have an angle between some sides? Yeah, I heard it a second ago. I heard you all say we have some vertical angles here. So if you mark those angles, write vertical angles, and then name those 2 angles. How do I name this one on the left? I like that, PRQ. How do we name the other one beside it? Good job, TRS. Alright, so those are my angles. So I just started off on side angle side. We just compared the angles. Now I got to compare these two sides. I got to have two sets of sides that are proportionate. So what's the key trick I've been telling you on which triangle to look at first? A lot of times we say look at the smallest, and look at the smallest number on that triangle. So that would be 9. 9 corresponds to what on the other triangle? 12. 9 over 12 is what? 3/4. Now let's look at the other sides. We have 18 corresponding to 24. And what is that? 3/4. Do we have side angle side congruence? Yes. So tell what method to use. This is the method we used. And this work right here, along with these angles and vertical angles, that is our proof that side angle side works. You got to be able to prove them. Now go down and try this checkpoint. Examine those triangles, figure out which method to use, and prove it. Alright, so the solution on this one. Whenever you're looking at two triangles, you have to examine what you know. I can see that I have 3 numbers on each side. That strongly emphasizes to me to consider side, side, side. When you're trying to prove side, 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 you're trying to prove 3 sides are proportionate. So, find the smallest triangle. Smallest number is 16. What's it correspond to on this triangle? 28. And that equals what? 4/7. Let's go back to the small triangle. What's the medium number? And it corresponds to what on the other? And that's also 4/7. The last one is the biggest number, so 32, corresponding to 56, and that's also 4/7. Are they all the same? And I've been comparing sides, so that's side, side, side similarity. We don't know about these angles down here, so be careful. Some people tried to prove stuff down here. You can't prove angles, just the sides. This is all you needed to write.